Hello everyone, and thank you for joining today's webinar, How to Architect a Successful Data Lake. My name is Brett Carpenter, and I'm the Marketing Strategist here at Zaloni, and I'll be your MC for this webcast. Our speaker today will be Raj Nadipalli, Zaloni's Director of Professional Services and Support. Now we'll have time to answer your questions at the end of the presentation, so don't hesitate to ask them at any point using the Ask a Question box below the player window. We'll also have a couple interactive polls for you to participate in. When the time comes, you can record your response using the Vote tab, also located below the player. But before we dive in, I'd like to introduce you to Zaloni. Put simply, Zaloni simplifies big data. We help customers modernize their data architecture and operationalize their data lakes to incorporate data into everyday business practices. We supply the Zaloni Data Platform, which provides comprehensive data management, governance, and self-service capabilities. We also provide professional services and solutions that help you get your big data projects up and running fast. Now with that, I'll turn it over to Raj to discuss what it takes to architect a successful data lake. Raj?
Thanks Brett for the introduction, and good afternoon everybody. So today's agenda, I'll just review that in a few minutes. So we'll first talk about the modern data architecture and why folks are moving to data lakes. Then we'll look at specifically what are the key challenges or failure reasons of data lakes. And then we'll move to how Zaloni talks about best practices to address those shortcomings. And then we'll move into the whole governed data lake with Zaloni software. And after that, we'll have some time for Q&A so that we can address your questions. All right. So before we move into data lake, let's just look into how the analytics space has been for the last 20-25 years. We've been in traditionally the data warehouse world, which this kind of an architecture, as you see in the picture, flowing information left to right. So we start from sources, and the sources typically were structured databases, which would have information from your transactional systems that moves to an ETL layer, extract, transform, and load, and that allows data to be then transformed into a normalized format that is designed for reporting in an enterprise data warehouse or EDW. And then finally, the consumption is through various BI reports and tools. Now, this architecture has served us well for several years, but it has limitations. Limitations specifically about it being rigid. It's designed for structured data. It's time-consuming to define the expressions and requirements, and then having dev team to actually analyze and build the solution based on that. And is also not agile. That is, to make a change, it would take weeks to months to actually make an impact to the final report. So fast forward, we are in this era of modern data architecture using data lakes, where all data is welcome, including data from structured as well as unstructured, and streaming. It's designed with that low entry of barrier to the data lake with the philosophy of schema on read. So that as you bring in all the data into your lake, which is cheap and cost effective and can scale and can take in any data, any format. Once it's in the data lake, the data does also have to go through the transformation or enrichment as required for the various business requirements. That still continues, but now that's all happening within this data lake concept. Optionally, you see that there's a flow going to EDW, and the reason it's optional in some organizations have and some don't. This is designed so that you can now use your older reports or legacy integrations and continue to go to EDW while your new or greenfield projects can go straight to your data lake. Your consumption is still your data analytics tools, but now these include the data mining tools and machine learning tools that can now also leverage data lake. So this is what is the promise of the data lake, which is where Zaloni is focused on to make this dream a reality, from where you see this picture to actually implementing it. So I think we'll take a quick poll to understand where this current audience is, where you folks are in your projects. So the question is, with your data lake rollouts, where are you in the current space? Are you actively using that in production with multiple use cases, or you've completed a POC and are working to actually roll it out in the next quarter or so? Or number 3 is you're planning to start, but you haven't started this initiative, or the last one where you don't have any, data lake requirements right now. So could you click on the vote tab and, select one option, please? We'll just give a few more seconds and then we'll move. So you can click on the vote if you have not already voted. All right, so we're going to close the vote in just 2 seconds. Please vote if you have not already. Okay, so I'm closing the poll. Now, let's look at the results. What we see is 15% are actually using in production. The rest are either planning or no plans at this stage, which is actually consistent with what we see in the industry. That we have less than 20%, clients who actually have some plans or actually are planning are in production. So that's 80% of the projects don't really make to production. And so while the concept is great from a data lake, terminology, and then also the expectations are high and the promise is high, however, we see the realization is not coming through. Now, there are multiple reasons, and I've listed the top 4 reasons from various case studies and articles done through different experts through Gartner and so on. And these are the 4 which we have seen as the main reasons. First is failure to produce a business impact. Now, while we're able to demonstrate quick success with a POC, the value of a data lake, at the end to the business is becoming a challenge, the ROI. So the ROI is what we've seen clients struggle with to explain the business as to why that investment and where that investment is going and what are the returns of the investment. And some of it is because of the fact that a data lake is being, in some organizations, just treated as a refresh cycle for a data warehouse, which can limit the potential of, what can be done through a data lake. So those are one main factor we've seen that businesses are not seeing an ROI. Number two is shortage of staff. That is the need for having skilled professionals in data lake is there, but it's quite not much in the market that you can go and hire, as we have seen in the industry as we try to hire skilled resources as well for our projects, and that's hard to find. And then number three is the governance. While data lake is great concept and the barrier of entry to data is very low, which is great. However, we want to avoid the scenario of the data swamp. That is, you have just data sitting there, and the visibility is low as to what's really in the lake. And then the question about, can I trust the data in there? Like, is it the right quality? Those questions are coming in from folks who have attempted and are not able to properly govern this data lake. And the last one is just the sheer complexity. While the big data concepts and Hadoop is a great open source technology, and Hadoop, as I say, is one word, but there are over like 100 projects inside it. So from an architecture perspective, if one has to stitch all them together, it's complex. And that complexity is becoming obvious when you start managing this in a production scale environment. So these are, I would say, the top 4 reasons what we've seen with our clients struggle with when it's the concept is great, but implementation is where we are struggling with. So I think there's one more poll coming up where we would like to ask this audience as to what you've seen as the key challenges. So there are 4 options. You pick one. First one is not sure how to leverage the data lake. That is, how to make use of the data lake from a business perspective. 2 is the skilled profession shortage. 3 is technology being too complex. And 4 is about the visibility of what's in the data lake. Now, I understand some may have multiple that you would like to pick, but we would like to get the top, so that's why you just pick one, please. So go back to your polling and you can select as to what's your top challenge. So please vote. We'll keep this open for a few more seconds to let you select the top challenge. All right, so let's stop the polling and then we'll see the results. So what we see is the lack of skilled professionals seems to be a top issue, which is definitely true what we see in the market. And the next 2 is a tie, which is the complexity in the technology and no visibility to what's in the lake. And the last one is the how to leverage the data lake. Okay, that's good. I think we'll go through each of these pain areas and talk about what Zaloni comes up with as recommendations. One area where we can't definitely help is the skilled professionals, because that's just how the market is. But we'll address all the other areas. All right, so moving to that best practices. So the first area I will focus on is organization. So this is the question about how do you leverage a data lake, and then also how do you show a return on investment. So this is what our best practices around this area is. Generally, the expectations are very high. That is, everyone thinks about data lake and has different expectations, and when you share that with management, each one has different goals in mind. So what we suggest is, while the idea of an enterprise data catalog, enterprise data lake, is similar with the concept of a unified data warehouse, so that goal could be obtained, but it's hard to start with that big goal and achieve it right away. What we suggest is to make it divide and conquer that problem. So if you define your data lake to be multi-tenant, so you design that with that right in mind, that you'll have multiple tenants, and each tenant could be your line of business or a domain or an area of your organization. And then you decentralize the governance aspect. That is, you allow these various lines of business have their own space so that they can define what they want out of a data lake. And the benefit of this one is, first, your architecture already allows, with the mindset that you can support multiple tenants like this. Two, you make the goals limited to each organization, wherein each one can define their success path within that data lake. And this, in my view, I think this is a recipe for success, because now you have the lines of businesses empowered to define what to do with that space, and then thereby also having those initiatives smaller and more controllable. This also can lead to your organizational maturity. As you've seen in the poll, the biggest issue is the lack of skilled professionals. So, which also means that when you can't get talent outside, then you start grooming the talent inside, which also means that when you start having various lines of businesses come up with their own success criteria, and limited success, even if it is, then they can start sharing that success with other lines of business, and thereby that knowledge sharing and leverage will increase, where you will understand how to use this new technology better. And that goes to my last point, where once you start seeing that each teams are able to demonstrate success, then you build this virtual center of excellence team. It doesn't have to be one organization, but you build this virtually, where you then collaborate on architecture principles, whether it's blueprints. You also share reusable components that has been built, and then you also share how the patterns are from usage perspective for analytics and machine learning. Okay, so that completes at least a best practice around how do you organize and the data lake, and how do you get ROI with divide and conquer. The next set of best practices are around the intake layer. So data ingestion is a key aspect that you need to start thinking about when you go to your data lake journey, because the first thing to work on data is you need the data in the lake. So while doing that, these are some best practices that we've suggested. You first want to think about registration as a process. That is, when you think about a system of record, SOR for short, is how do you register that source in some systems, so that there is a place to look at the different data feeds from the different sources. There's also some metadata around what to do with each of those sources. And once you have that framework, I would call in place, then you can build reusable components that, like for example, we have clients that deal with, let's say, VSAM episodic files. So once you build a pipeline to, set the copybook, define your, the criteria, and then you define your structure as you want that in the data lake, then you can reuse the same using that metadata. Similarly, when we talk about XML, JSON, or text files, once you define a pipeline, then you can reuse it if everything is, governed through metadata. And then you also have to start thinking about the data lake from storage perspective. That is, how do you handle full loads, incremental loads, and how do you handle change data capture and so on. So all those scenarios come into play, and then you build once and then you reuse multiple times if it's governed through metadata. And then finally, and but not least, is the operational information. So this is crucial for making things go to production. That is, if you are getting omnichannel data feed coming in every day, how do you know that today's load was successful? So the operational stats and visibility to that operational stats is crucial that your consumers have that. So that's the best practice around data ingestion. All right, so the next is about governance. So regarding governance, and this is the area where you want to avoid that data swarm versus a data lake, is how to build the metadata around the data. So first is what we say is you need a catalog which shows what's in the lake. And this catalog should also have ability to tag so that you are able to find what data is raw versus what data is trusted, what is enriched, and so on. So each of, as the data goes through the various life cycle, you will see that the data is cataloged correctly. And then, in addition to what I call automatically tagging based on where the data is and what data technically says, you also need ability to crowdsource, because there could be information that technically it's not known, but it's known by someone in the business as to what this data set really has or what this value in this field means. So that information is also critical for us to capture that and show that in the catalog. And then from a governance perspective, we need to have ability to do the complete life cycle from the data being on the raw to trusted and then moving to the refined zones. So this end-to-end life cycle and management is also required as part of the governance. All right, so that covers the governance best practices. So this is a lot of information here, but what we're trying to explain is as the new architecture is coming up, if you start thinking of each of those aspects and make blueprints and reference architectures for those, then this will ensure that your data lake project is more successful. All right, the next section is about self-service. So this goes to the question about there's no visibility in the data lake. Now, how can we achieve that or shortcoming? The way to achieve shortcoming is to we need ability that we can have the marketplace experience. That is, think about how we're used to the Amazon kind of catalog where you can go in and search for things based on various categories and based on terms and so on. Similarly, we need to think about how data can be searched in the data lake using that same concept, and that should be the end consumers should have that self-service ability, that they should be able to go in and search for it. We also should have ability to not just search, but have the consumers able to provision that to the sandbox, which is a common requirement that not only I want to search for my stuff, but I want to check it out, right? So check out and then provision that to some other area where then I can run my own analytics jobs and so on. We also should have controls and policies around how long, and first of all who got access, and then how long they get to keep that copy of the data, so that it's all controlled for compliance reasons. So that's the set of best practices for the self-service. So that actually completes as a summary where we are talked about so we talked about best practices around overall organization and multi-tenancy. We talked about the ingestion, and then we talked about governance, and then self-service. So now there is another aspect for overall architecture, which Zaloni calls it the zone-based design. And we've seen this reference architecture in different forms in different clients, which I'll cover through in a little more detail now. So zones, first of all, why do we care about zones? Because zones allows the data being from, data lake becoming a dumping ground or a staging ground to actually more structured. And this is required because in the big data space, the life cycle of data always evolves into different forms. And as it evolves from being raw, pure data to actually information, it goes through a journey. And this architecture allows that structures in place so that it's easy to find the right data and understand the attributes for it. It also eliminates duplicates and silos, and it manages the space more efficiently. So in the next slide, I show the reference architecture for Zaloni's zone-based architecture. And I'll start from the extreme left, and then I'll go left to right. So left, you see the various source systems, relational sources, logs, sensors, social channels, if you're getting, for example, Twitter feeds. So data, this is what's known as external sources. And what's inside this whole box here is the data lake. Now, within the data lake, you see the different sections. First, I'll talk about the transient, and then we'll go through the other zones. So the transient zone is the first, what I call landing area. This is a temporary storage area where you can land the data first, as the data lake's promise is to, low barrier of entry. You just land the data as soon as you get it. Now, once it's in here, then you would do some checks and balances before you actually, make that available for others. For example, if this data has any PII or PHI data, then you would tokenize that and then move it to the raw zone. The raw zone is what we call the data where it's close to your raw data, except that this is not temporary. This is going to be storing, let's say, 7 years of data, if that's your retention period for core data. So this is now more broadly consumable, and it's as close to the raw data. Now, from the raw zone, the data is then moved optionally to the trusted zone, and this trusted zone could normalize the data if required from the raw zone. For example, you might have customer information in 4 tables in the raw zone. One could have the name, one could have some address, and one could have other account details. And if you want to combine all of those and create one record for a trusted customer, then that could be what happens between the raw and trusted now stores the record of what a customer means. And the refined zone is when you create aggregates or summaries, for example, on top of the trusted data. And finally, the sandbox, that's the area where you can have your data science run some machine learning on data. So they would get a copy typically of the data from either the raw or trusted or refined, and then this copy is retained for X number of weeks till their data science experiment is done. So for each of these zones, I do have detailed slides, and I'll just go through one of them, and then we will let the others come. Others you can review that through the slides that's shared. And each of these zones, the way these detailed slides are structured is this talks about, let's say example is transient zone. It talks about what is the input for the transient zone, what is the output from the transient zone, what are the processes that are running, and what are the policies that go on this area. So for each of the zone, we have structured it this way. Now, from the way this reference architecture should be used is each organization will have different naming conventions for this. So for example, some clients call this bronze, gold, and silver. Now that's okay, and some would have different names for each of these zones. That's fine. But what we suggest is you still need to define what data goes into that zone, what data goes out, and then what happens in that zone. So, and then who gets access to it. So each of those zones should have this level of details that your organization then can adopt and use. So for example, the transient zone input can be is the external source systems, which is RDBMS files and streaming. Output is the data goes from transient to the raw zone. The processes that happen here is we register the metadata, we apply zone-based policies, then we capture operational data, we do post-ingestion validations, and so on. On the policy side, you could see tokenization and masking would happen here. We would also have some security restrictions. For example, you want to define some policies as to who can use this data, then we can put that in as well. Okay. And as far as the data life cycle management goes, this zone would have data only for temporary time, so it's the duration is short. So similarly, I have details on each of these zones, which I'm actually going to skip, as you can review that in detail later. But the idea is that you would, as an organization, define this and then use it so that you have clarity on what's in the lake and also it's well structured. Okay. So now let's talk about how the data lake is governed using ZDP. So now before we go there, we just want to call out the Zaloni's thought process on the maturity model of organization. So what you see here is the various phases an organization goes through. That is, you first start with the ignore phase, where it's purely a data warehouse, and you're still not sure that you want to move to a data lake. The next phase is store, where the decision is now made to go to a data lake, but you first start with the data swamp because there's no real governance. The next phase is where you have the governed data lake. Now this is where we think most of our clients are at, where they understand the value of the data lake. Now they're trying to govern it. Which includes like capturing the right metadata, making it visible, putting some governance like the zone-based architecture and policies around it. The next phase, what we see as where this industry is going to go to, is automating. That is, we want to automate how to do ingestion, and make the data more available through self-service mechanisms, so that it becomes natural and easy to adopt this architecture. And then finally, what we see is the phase being optimized, where not only we start automating, but we think that data lakes should have the ability to self-govern themselves, or self-organize themselves, so that the data is available to the right people easily, quickly. So now, where does with that thought process in mind, we'll tell you what ZDP does today. So today, ZDP, Zaloni Data Platform, has these following capabilities. So the way I will show this is what I call the three pillars. So the three pillars are enable, govern, and engage. So enable pillar handles the ingestion area. That is, as I talked about, ingestion is the first thing that happens for any data lake from a journey perspective. We have ability to define batch, streaming, or ingestion modes easily through our interface and configure them that way you don't have to develop this intake application or a program. And it's managed meaning that it not only lets you configure, it'll do the ingestion from the, let's say, the landing zone directories into the data lake, but it'll also start organizing them as we showed in our reference architecture to the right zone. It also does metadata capture automatically, so that you don't have to think about the catalog, later. It's done as part of the ingestion. So every file that's ingested automatically shows up in the catalog. It also has the ability to auto-discover. These are scenarios where you already have a data lake, but you want to, still use ZDP from a catalog perspective. From a governance perspective, we have data quality features built in so that you could run data quality on the cluster using ZDP software. We do data mastering as well, so that you can look at defining your golden record for, let's say, a customer coming in from various different subsidiaries, for example. All of that can be mastered using big data technologies, using ZDP tool. We also have enrichment and features for tokenizing and masking the data. And then on the engage side, we have the catalog that you can now browse and search for data using the metadata tags, and you can do self-service ingestion as well as self-service data preparation. The foundation of these capabilities, or these three pillars, is the cluster. So this cluster can be either cloud, on-prem, or hybrid, or multi-cloud. It doesn't matter. ZDP has features to work in all environments and even hybrid environments. Okay, so this is a little bit deeper dive on that previous slide as to what's happening inside the covers. So you can see, I'll go from bottom to top. On the bottom, you see the different, HDFS, MapReduce, Hive, Spark, Scoop, those components that is foundational for ZDP to work. We complement this. We are not replacing this. So those will be in the bottom of the stack. And then on top of it, we have this layer in yellow, which is ZDP software that allows the managed ingestion, metadata management, DQ, enrichment, operations, and security, and so on. On top of that is the catalog in center, you could see. And then finally, for consumption perspective, we have self-service ingestion, preparation, and provisioning, all part of the end user capabilities. We also integrate with governance tools. If you have, let's say, IGC or Colibra that you use for enterprise level management for metadata, we can integrate with that. And we also will be complementing the BI tools. We are not doing visualizations at this stage, but we can easily enable visualizations, so we say that those softwares can integrate with ZDP. Okay, so this is our last slide. Here I talk about reference architecture that we used in multiple clients. Here the way you see this is from left to right. Information is going from various source systems, and then what you see is first data goes to the edge node. So the SORs is a system of records. Data goes to first the landing zone or the edge node where ZDP would be installed, And after that, the ZDP agents move the data or copy the data from here to the transient zone. From transient zone, data goes to the raw zone. Then from raw zone, it can go to the refined zone, and then you can have consumers use that. As data flows from left to right, there are various processes that happen, which are shown below. For example, when we look at when the data goes in the transient zone, we are doing file-level data quality checks for looking at, say, duplicate files. We also do field-level validations, and we also do Parquet conversions as part of the raw zone process. So those you can define as to which step you want in which zone as part of your defining your pipeline. The bottom of the stack shows the different core capabilities or functionality that we get out of the box, which include ingestion, workflow management, catalog, data quality, and DME. Okay, so now we'll open for Q&A to the audience.
All right. Thanks, Raj. All right, so we're going to have this time for questions. If you have any, please be sure to use the Ask a Question box that's located just below the player. We have had some come in already, so we'll go ahead and get started answering those. And if you have any come up, feel free to ask them. So these first ones are very similar. So which tools can we effectively use to explore the data lake? Are there visual or drag and drop tools?
Sure. So there are many tools you could use in the big data space, and it would depend as to where you are, whether it's cloud or on-prem. On-prem, you can, leverage your, let's say, Click or Tableau, or business objects if you have those. So those tools can be still used if you're using from your on-prem. Now on cloud, depending on whether in Amazon or Azure, it has different tools like QuickSight is what AWS pushes. So each environment has different tools that you can use to visualize your data.
All right. The next one is, could you elaborate on data governance of transaction data in the data lake?
So from a governance perspective, the way we should think about is, as data comes in, how do you ensure that the data is the right quality, right? So one way what we've done with clients is, you first start defining your standard data quality checks. For example, some things could be avoid, you should not have duplicate data. So that's kind of fundamental. Two, you have the right data type in the right column. So those, what you could do is we call technical checks and balances. So those you can define for all your systems, and as data comes in, you would do it. Now, on top of that, if you want to do some kind of a business level checks, then you can define more complex rules, and that could be authored by your data stewards who know more about the data. For example, if you want to make sure that the quarterly results have numbers that are aligned with with only 2% variation to the last quarter, then that's like a business level check that has to be defined, and then you can put that in place as you ingest the data to make sure that happens.
All right. Let's see. What options are available to enable self-service to a non-technical user?
Yeah, what options? So what we do from self-service perspective is we have a catalog that's very easy to use, and that's the what we call Google-like experience on data or metadata, where you can search, and that can be used by any non-technical user. Now, we think about not just search, but we also think about giving them the preview of the data as well as profiling results right up at the time they search for the data so that they know what they're looking at. So that makes self-service easier to at least shop for data. There's also features that we have to make the ingestion easier so that ingestion can be done by self-service, and also provisioning at the end, which is getting the data out.
All right. Let's see. Next one is the data lifecycle is not the same as ETL. Does it thus inherit the same problems and costs of ETL?
So ETL, which stands for extract, transform, load, has been used from data warehouse terminology. So the life cycle of data in a data lake is also has to go through what I call transformations, but the journey is a little bit different. That is, here it's schema on read versus schema on write compared to ETL. Now, the question is about the cost, right? The question was about cost, right? So I think what I would suggest is think about this with a different lens. Don't use the same ETL methodology, because the approach taken on ETL was heavy modeling of the data, and in data lake, the results can be obtained maybe through lesser hops, but using different technologies like Spark and so on.
Okay.
But the question about cost still is there. You still have to incur a cost for building the transformation. So that doesn't go away, but the solutioning is different, because now you can define and be more agile with the data compared to your traditional ETL systems.
All right, great. So the next one is, let's see. I guess, doesn't trusted zone equal EDW? Doesn't it need ETL? What is the gain versus EDW with ETL?
Yes, so trusted zone is so the trusted zone data can be pushed to EDW. That's fine. I think that you could define from your zones are in this what I call logical. The physical implementation of these zones could vary depending on how you structure your data lake. And you could define that your trusted zone once you want to send a copy of that data to EDW, which is fine. That's architecture decision that you guys have to make for your organization.
Okay. So I guess the next one, EDW plus ETI is already automatable, but what is the scenario for data lake?
I'm not following this question. It's already
okay. All right, so we can
maybe we can have a separate discussion on this. If you who were asked this question, put more details on that. Yeah.
Okay. We've already answered the data visualization. And we've touched on what kind of consumers. We have both tech and end users.
Mm-hmm.
So what specific advantages does the ZDP provide over the cloud provider offerings?
Sure. So if you look at AWS, Azure as your top, which are the top providers, or Google, all of them have the ability to store and compute data. What ZDP brings on top of that is that management aspect. For example, let's say you look at AWS EMR. So you can store the data in S3, but for compute, you have to spin up a cluster, whether it's EMR or HD inside in Azure. Now, when that's happening, you still have to define a place where you store the metadata about the files. You also have to store your job definition as to, let's say you've got a new file of Omniture that you want to process, then there has to be some metadata to drive that. That's what ZDP provides. That way you can have an orchestration layer that can take the data, run through the different life cycles, and also let's say you want to do the data quality checks. That is also something you can do in ZDP. So ZDP overall manages the life cycle of data. Azure and AWS provide the core components that ZDP will leverage. So they actually complement each other.
Okay, this next one has some details, but I'll try to shrink it down for you. Do you see the data lake as a single platform, for example, S3 or Hadoop, or do you see it as a distributed data lake?
Mm-hmm. Yeah, so what you're seeing is traditionally clients have started with an on-prem data lake before cloud was too popular, but now we're seeing the shift to cloud, and while that shift to cloud is happening, some organizations are in between. So they have, for example, let's say some data sitting on-prem and some data sitting on cloud. And so what we see is the data lake management, or like something like Zaloni is key to make that journey easier. For example, if you define your jobs that run only on, let's say, your on-prem Hadoop distribution, and if you want the same jobs to be run now on data hosted on S3 and Amazon, then you need some interface. And that's what we provide. Now, from a concept of a data lake is, in our view, is hybrid, can be hybrid. It doesn't have to be on-prem or cloud. It can be both.
Okay. Next one is, what's Zaloni's value proposition in the data lake journey?
Yeah, so I think we discussed this a few questions ago as well. That is, we are adding that the value add here you see is those, when we look at the top failures, and some of this came from the audience as well, is how do you know what's in your data lake? Now, to answer that, you need a catalog. So ZDP provides the catalog automatically. Second is, how do you manage this? Because as we heard from the audience as well, is this technology is pretty complex. So let's say you have, Kafka and Flume agents that you need to configure for one source, and the other place you want to do file-based ingestion, and the third place you want to push your data to Redshift. Now, these different components that are there in the ecosystem make this journey pretty complex. What Zaloni is adding value is making these pretty much like your, connect the dots. So you define those configurations and pipelines in ZDP, and your development timeline reduces or shrinks because ZDP figures out how to communicate with those different components and make that stream easy from the development as well as the consumption use cases.
Okay. See, there's only a couple left. How is the refined zone different than aggregate or summary you can create on top of DWDM? Yeah.
So the refined zone, again, as I said, these zones are the concepts, right? This is a reference architecture, and the refined zone does store the aggregated or summary information. Now, if you do have a data warehouse that complements or that's part of your data lake architecture, then some of this aggregation can be done straight in, let's say Teradata, Netezza, or Oracle, whichever is your data warehouse. And that's fine. Then you could make your trusted zone, your aggregated or refined zone as part of your data warehouse, which is fine. But in case you don't have that and you want to be completely native and have this in the data lake, like Hadoop based, then you would put that as a zone in HDFS.
Okay, and then I think the last one is, can a streaming tool achieve real-time analytics, for example, in a fraud use case?
Yeah, I mean, we've seen clients actually use that. So I have worked with a client that was doing, IoT-based analytics on understanding, for example, finding out who left a cell phone in the, visitor area, which was not there like 2 minutes ago. So these use cases are actually, being achieved with an architecture like this. So it is all definitely possible using, MQTT or Kafka streaming, and with a combination of Spark streaming to analyze this data.
All right. Yeah, so I think it looks like that's all the questions that we have. I want to thank all of you for joining this presentation, and to Raj for taking the time to speak with us today about architecting a successful data lake. This presentation will be available on demand, both on Zaloni's Resources Hub and on BrightTalk for future viewing. And the slides will also be available in the details or the attachments section below the player. And as a quick mention, advance this, there we go. Zaloni will be at Strata, New York next month. So feel free to swing by our booth, which is number 1115, to get all your data lake questions answered and receive a demo of the Zaloni data platform. We'll also be giving away free copies of Architecting Data Lakes. So with that, we appreciate your time today. Thanks again, and we'll see you next time.